Celsius and the Fahrenheit scale. So one by one, we'll be discussing about all of them today. So starting with the first scale, which is called as the Celsius scale. So this Celsius scale in around like 1973, in around 1743, Anders Celsius invented this scale. So because of his name only, the name is given Celsius. So Anders Celsius invented the Celsius scale. So he invented this part. Now what he also determined, he determined the freezing temperature. He determined the freezing temperature for water to be at 0 degree and the boiling point or boiling temperature at 100 degree. Now when we talk about this scale, at this scale 2 points will be there. The first one is the freezing point or temperature and the second one is the boiling. So in the case of the freezing, the temperature is like 0 degree, and whereas for the boiling it is 100 degrees Celsius. So whenever in the question if it comes that in the Celsius scale what is the freezing point, the answer will be 0 degree, and what is the boiling temperature or boiling point, then it will be 100 degree Celsius. Now on this scale there are 100 divisions. So on this scale what are there? There are 100 divisions between these 2 points. So between the 0 to 100 degree Celsius, there are 100 divisions in this scale. So this scale is called as the Celsius scale, where the boiling point or boiling temperature is 100 and the freezing point of freezing temperature is the 0 degree Celsius. And between these 2 points, how many divisions are there? 100 divisions. Like you might have seen in the scale also, right? 1, 2, 3, 4, then 1, 2, 3, 4, 5, like this. 1, 2, then again the same thing, right? You might have noticed like this in the scale. This kind of division, this kind of structure is called as division. So same thing, same kind of division will be there in the Celsius scale. Coming to the next one is the Fahrenheit scale. So this scale was developed by a scientist known as Daniel Gabriel Fahrenheit. Now you can see in the name, the Fahrenheit word is given, and that is why it is called as the Fahrenheit scale. So this was developed by Daniel Gabriel Fahrenheit, and the unit of this scale is degree Fahrenheit. The unit of this scale is degree Fahrenheit. Now on this scale, what happens is, like the previous scale, the boiling temperature and the freezing temperature was there. Same way, here on the Fahrenheit scale, the freezing point is 32 degrees Celsius. The freezing point of water is what? 32 degrees Celsius. Whereas the boiling point of water is, any idea how much it is? On the Fahrenheit scale, how much the boiling point is? 212 degree Fahrenheit. So the boiling point is 212 degree Fahrenheit, whereas the freezing point is 32 degree Fahrenheit. But in the Celsius, it was 0 degree for the freezing, and for the boiling, it was 100 degree, whereas for the Fahrenheit scale, the freezing is 32 and the boiling is 212 Fahrenheit. Coming to the division, there are 180 divisions between these points. So between these boiling and freezing points, there are 180 divisions. But in the Celsius, how many points were there? How many divisions were there between these 2 points? In the case of the Celsius, how many divisions were? 100. 100 divisions were there. And in the case of the Fahrenheit, 180 divisions. Yes. So in the case of the Fahrenheit, 180 divisions are there between these 2 points. Coming to the last scale is called as the Kelvin scale. In the case of the Kelvin scale, it was invented by Lord Kelvin. So see, you can see all the 3 names of the scale has been come from the name of that particular scientist. So Lord Kelvin has invented the scale. The unit of the scale is the Kelvin, which is denoted by K. And on this scale, the freezing point of water is 273 Kelvin, whereas the boiling point is 373 Kelvin. So when we talk about the Kelvin, the freezing point is 273 and the boiling point is 373. Now, if I sum up all these 3 together, so here we'll write about the scale, what kind of scale we are talking about. Then a freezing point of water. And at last, what should be there? The boiling point of water. Now, this is the easy way to learn. You have to make a table like this. Now, name of the scale we should write here. So first I'll write degree Celsius. Then secondly, I'll write the degree Fahrenheit. And then last one is what? It is the Kelvin scale. Now you tell me what is the freezing point for the degree Celsius? It is
0 degrees.
0. For the Fahrenheit?
From 32.
Yeah, 32. And for the Kelvin? 273, right. Now boiling point of the water is
100.
100. What is the boiling point of the Fahrenheit?
212.
Very good. 212 Fahrenheit. And the last one, the Kelvin, has the 373 degree Kelvin. So these are the important points to remember. Degree Celsius, freezing point 0. Fahrenheit, freezing point 32. Kelvin, freezing point 273. Whereas boiling point for the Celsius is 100. Fahrenheit 212 and Kelvin 373. So these are what? They are the scales which are given there. Now, there are 2 points present here on the all scale. The first point is called as lower fixed point. 2 points will be there on each scale. The first point is called as the lower fixed point, and the last one is called as the upper fixed point. So like 0 was the less and the 100 was the highest. Same way 32, 212, then 273, 373. Like this, the down one will be the lower and the last one will be the upper. So 2 points will be there on each scale. Now, if we want to find out basically the conversion of the relation, what we will be doing, whatever the temperature is there, we need to find it out using this lower point and upper point, fixed point on the scale. Now, how we'll be doing it? Temperature on scale. Find temperature on scale minus lower fixed point divided by, so temperature on scale minus lower fixed point divided by upper fixed point minus lower fixed point. So this is the formula how we'll be finding it out. Temperature on scale minus lower fixed point divided by upper fixed point minus lower fixed point. Now, temperature on scale means either Celsius, either Fahrenheit, either the Kelvin. So what do we write? We write TC. T stands for temperature Celsius, Celsius temperature. All right. Then minus, what is lower fixed point for the Celsius? The lowest point for the Celsius degree scale. It is 0. Correct, Varshit. It is 0. So we'll be writing 0 here. Now divided by upper fixed point. What is upper fixed point for the Celsius?
100 degree.
100. Correct. 100 degree. Minus, now what is the lower fixed point?
0.
0. So that is how we calculate this. Fine. Now, same goes for the other type of scale. Now, for example, we have the Fahrenheit scale. Same formula we have to apply, which will be writing TF minus what is the lower scale, lower point there in the Fahrenheit?
32.
Correct, 32. Divided by upper point minus the fixed minus the lower point. What is upper point here?
212.
212 minus 32. So that is how we calculate for the Fahrenheit. And the last one, same way we'll be calculating for the Kelvin, which is TK minus 273 minus divided by 373 minus 273. So that is how they are connected, or we can convert them into the different forms of it. Clear? So these are the like formulas which will be used in your higher classes, as well as few might be there in your grade 7. So these are the 3 different scale: Celsius, Fahrenheit, and the Kelvin scale. You should know about the freezing point and boiling point. So Celsius scale was invented by the Ender Celsius, and he determined the freezing temperature at 0 degree, and the boiling temperature is 100 degree. Whereas in the Fahrenheit, it was developed by the Daniel Gabriel Fahrenheit. Freezing point was 32 and the boiling point was 212 Fahrenheit, and 180 divisions were there between these 2 points. And the last scale, Kelvin scale, it was invented by the Lord Kelvin. Freezing point was 273 and boiling point was 373. So this we have sum up for all 3 scales, and then the formula of finding all those things. Now coming to the next topic are the thermometers. Thermometers. What are thermometers?
An instrument used to measure temperatures.
Okay, good, Kritvik. The instrument which is used to measure the temperature. Okay, what are the different types of it? Anyone? And turn on the video, Anubhav and Yashwan, turn on the video.
Ma'am, digital,
Okay, digital, apart from the digital?
clinical and laboratory.
Correct. Clinical also we have the laboratory. So normally at home, which thermometer do we use?
Ma'am, digital.
Digital.
Correct. We use the digital thermometers. So by using the digital thermometers, I think within a few seconds or few minutes, we'll be able to identify the temperature of our body. So different thermometers we'll be discussing now. 1 minute. So I'll show you these scales, the thermometer. First of all, what kind of thermometer? Okay, let me share the screen.
Measurement of temperature. It is possible to identify whether the object is hot or cold with the help of temperature. How do we measure temperature? In hospitals, you might have seen doctors using a device for measuring temperature. What is it? It is a thermometer. The type of thermometer which is used to measure temperature of our body is called a clinical thermometer. Let's understand its structure. It is a long narrow tube with same thickness throughout the length. On one side of this tube, there is a bulb which contains
So you can see in the
mercury.
picture the thickness will be same from one division to the last division. Everywhere the thickness is same. And the end of this thermometer, there will be bulb, and inside the bulb there will be an element called as the mercury.
For reading the temperature, there is a scale printed on thermometer. The normal temperature of human body is 37 degrees Celsius. However, it can vary between 35 degrees Celsius to 42 degrees Celsius. Therefore, the clinical thermometer has reading from 35 degrees Celsius to 42 degrees Celsius.
So if we take it from the 0 degree to 100 degree, it will be like we will not be able to hold the thermometer in our hand, right? That is why the clinical thermometers are made in such a way that the between readings are there and it becomes small and handy to carry it.
Here, you must have understood that 35 and 42 are numbers and degrees Celsius is a unit of temperature. There is a very fine tube which originates from the bulb. It is called capillary tube. With rise in temperature, mercury expands in this tube. The capillary tube
So now
is
with the help of, as soon as like the heat, our body generates the heat. As soon as the temperature of our body increases, with the help of that heat, what happened? The mercury will start expanding. It starts melting out and starts moving into this tube called as the capillary tube.
vent near the bulb. It prevents mercury from flowing back into the bulb immediately. It gives more time to read the temperature. To get more correct reading, there are some divisions between two consecutive numbers. If there are 10 divisions, then each division signifies 1 by 10, that is equal to 0.1 degrees Celsius temperature. And if there are 5 divisions, then each division suggests 1 by 5, that is equal to 0.2 degrees Celsius temperature. How to use a thermometer?
So depending on the type of thermometer you're using, and different, clinical thermometer has a different kind of division. Some will have the 10 divisions in between and some will have the 5 division. If it has the 10 division, then it means 0.1 degree Celsius for one division. And if it has 5 division, then for one division, it means 0.2 degrees Celsius.
Before using thermometer, you should wash it with some antiseptic solution. Also, give some jerks to it so as to bring the mercury level falls below 35 degrees Celsius. Now, place the bulb of thermometer under your tongue. Keep it as it is for 1 minute and let the mercury expand in the tube. Now, take the thermometer out and find out the reading shown by the mercury. Just now you have identified your body temperature. Here is a sample value which is showing 37 degrees Celsius and 0.
So you can see the 37 degrees Celsius, it is there. But beyond the 37 degree also, the mercury has expanded. And it has reached to 4th division. That is why the temperature will be 37.4 degree Celsius.
4 degrees Celsius. That is 37.4 degrees Celsius. For temperature measurement, there are units other than Celsius, such as Kelvin and Fahrenheit. Their scales also vary from that of Celsius scale. Always remember, never use a clinical thermometer for measuring the temperature of hot objects other than human body.
Why we should not use for the hot object, the clinical thermometer? What will happen if we use it for the hot object?
It will expand too much.
Okay, it will expand. So what happens if it expands?
It could even explode now. It could even
Correct. So what happened? It will explode or it will burst out, because mercury is present in the bulb, right? At the bottom it is present. And if we provide lot of heat or lot of flame to it, or we use the hot object in front of it, what happens? The mercury will not be able to hold itself and it starts expanding, and because of that the explosion will be there. And since the thermometer is made up of glass, it can expand a lot. So that is why we should not use it for the hot material or the hot object. Only for the body we can use, because our body is not so hot. Okay. Now, the first thermometer, basically they are what? They are the instrument used to measure temperature, is called a thermometer. Now, different types of thermometer are there. The first thermometer, let me discuss, is about the clinical thermometer. So you have seen the structure of the clinical thermometer right now. So clinical thermometer, they are commonly used thermometer. They are the commonly used thermometers, and it is made up of a narrow tube of thick glass. What is the name of the tube? It is called as capillary. So it is made up of a narrow tube called as capillary of thick glass. Third point, at the end of capillary tube will be a thin glass bulb filled with mercury. So at the end of this capillary tube, what will be there? The mercury will be filled in it. At the end of capillary tube is a thin glass bulb filled with mercury. So mercury will be filled in it. Then what temperature is mentioned on the clinical thermometer? From where to where?
35 degrees to 42 degrees.
Very good, very good. So it can measure temperature from 35 degrees Celsius to 42 degrees Celsius. So that is the main point of this. It can measure the temperature from 35 degrees Celsius to the 42 degrees Celsius. And what is the normal temperature of a human body in Celsius?
37 degrees.
Correct. Good. So normal temperature of human body is 37 degrees Celsius. Since our temperature is between 35 to 42, that is why the clinical thermometers are made in such a way that the divisions are given from 35 to 42 degree Celsius. Now, why this capillary tube is present in the clinical thermometer? It's very important question. So why the capillary tube has a bend? You might have seen in the capillary tube a small bend was there. Like suppose this here the mercury was filled, and after the filling of the mercury a small bend was there. So why this bend was there in this thermometer? What was the reason?
Without the mercury going back to the.
Very good, very good. Correct. So the capillary tube of a clinical thermometer has a bend. So this is called as bend. This structure is called as bend that does not allow the mercury to flow back, and that is the reason the bend is present. So it does not allow the mercury to flow back into the bulb. That is why the bend is present. Fine. Now, what are the precautions we should take while using this clinical thermometer? First of all, we should wash this before using. So, wash before using. And by what kind of thing you should wash? You should wash it with the antiseptic solution. So, you have to use the antiseptic solution for washing the thermometer. Then the thermometer should be kept straight to find out the exact reading. So thermometer should be keeping the level of mercury along the line of sight. So wherever we are seeing, there we should always make sure the mercury is present in a proper way, in a correct form, so that the correct reading can be taken. Then the thermometer should be handled with care. We should be very careful while handling the thermometer. Then the bulb of the thermometer should not be touched. So we should not touch the bulb of the thermometer. The bulb of the thermometer should not be touched. So when we touched it, might be the reading can change a bit. So that is why we should not touch it. So that's about the clinical thermometer. Now next type of thermometer is the what are the your laboratory thermometer. The next type of the thermometer are the laboratory thermometer. Have you seen those thermometers somewhere? Laboratory thermometers?
Labs.
Where?
Mom, in labs.
It will be like so big in structure. Wait, let me see if I can show you. I'll show you this.
सुकून से मुलाकात कराए ताजमहल चाय वाह ताज
ज्यादा पोषण ज्यादा देखभाल डाव अब 20% फ्री
So this is about the laboratory thermometer.
Laboratory thermometer. Subscribe the channel and press the bell icon to get latest updates from learnfatafat.com. For measurement of body temperature, we use clinical thermometer. However, it is not suitable to measure temperature of other objects. For measuring the temperature of other objects, we use laboratory thermometer. Watch ad-free and complete syllabus on Learn Fatafat Android app. Download the app now. There is a bulb at the side of thermometer. A narrow tube having same thickness throughout originates from the bulb and extends towards the highest reading. A tube formed by this bore is the capillary tube. Generally, the laboratory thermometer have scale between -10 degrees Celsius to 110 degrees Celsius. There are 10 divisions between each consecutive numbers. That means each division indicates 1 degree Celsius. While measuring the temperature, we should follow some practices to get correct reading. Take the sample of which we want to measure the temperature. Here, we will take some warm water in a beaker. Now place the thermometer vertically such that the bulb remains immersed in water but does not touch the beaker. When the expansion of mercury stops, notice the reading in the thermometer. Here, it is 45 degrees Celsius. We should take the reading while the bulb is immersed in water. It is because, like clinical thermometer, there is no bend in laboratory thermometer. Hence, as soon as we take the thermometer out, the mercury starts falling down rapidly.
So we have seen that in the clinical thermometer, when the bend was there, and with the help of the bend, what happened? The mercury will not come back easily. It will take some time. And easily we can see the temperature. We can read the temperature. But in the laboratory thermometer, there is no such kind of bend present in the thermometer. And that's why when we are immersing this laboratory thermometer to take the reading, as soon as we have immersed, we have to wait for some seconds and then we have to check the reading immediately. Because if we take the thermometer out, then reading might change and we will not be getting the appropriate temperature.
That is, the level of mercury decreases, due to which we did not get the correct reading. Remember, we cannot use laboratory thermometer for reading body temperature. It is because of the same reason. That is, until we read the temperature, the mercury level decreases.
So if we try to use this laboratory thermometer for our body temperature, then same thing happened. Like for example, I have kept this thermometer on my tongue, under my tongue. Then if I want to see the temperature, I will be taking the thermometer out. As soon as I take the thermometer out, the reading of this thermometer will change, will fall down. That is why we should not use the laboratory thermometer for the body temperature. Rather than you should use a laboratory thermometer which has a bend, and because of the bend, it will take some time to go the back
rapidly. Here we complete this topic.
Okay, so that's about the laboratory thermometer. We'll discuss few points on it. So this laboratory thermometer is also called as mercury in glass. It is also called as mercury in glass. It also has the long glass stem with a thin uniform and close at one end. So at one end it will be like closed, whereas at the other end will have what? It has a small glass bulb. So other end is attached to a small glass bulb, and it is filled with which element? It is filled with what is filled inside this?
Mercury, ma'am.
Correct, mercury. Fine. Now, when the bulb is heated, what happens? The mercury will expand and it flows into the bore of the stem. Bore is basically the center part of the thermometer. So as soon as what we do, we heat this part, then the temperature will start moving up into the bore, and it goes into the center part, and where we can read the temperature. So now we'll see the what precautions we have to take. As we have seen in the video also, we have to first of all handle it with care. So handle with care, and we should not hold the thermometer by the bulb. Do not hold the thermometer by bulb. So because when we hold by the bulb, then the reading might disturb and the mercury level also can change to it. Then we should keep the thermometer upright. So thermometer should be always kept in the upright position, not tilted. It should not get tilted, because if it get tilted, then reading might change. And very important, it should not touch the surface of container. If the bulb touch the surface of container, then again the reading will change. So bulb does not touch the surface of container. So these are the few of the precautions what we need to take care of. And the last one, it is the digital thermometer. You all have seen it so well. In your home also you have those digital thermometers. So these digital thermometers are basically advanced form of the thermometer. They are used to measure the body temperature. Then they work on tiny dry cells, right? You might have seen like inside these thermometers what will be there. There will be tiny dry cells will be there inside them, and with the help of these dry cells only they work. Now these digital thermometer, they are the safer. So it is a safer device. These digital thermometers are safer device because it does not contain mercury, right? It does not have mercury, does not contain mercury. And what is mercury? Mercury is a toxic substance, and that is the reason that this digital thermometer are what? They are the safest device to use. And its body has a plastic covering, so plastic body, and is easy to use. So it is like very easy for us to use. It also gives us the accurate and specific reading. So the reading here will be the accurate and it will be so specific. That's why like nowadays the people, they are using this digital thermometers most. Fine, let me get this thermometer. I'll show you the thermometer. Just a minute. Yashwant and Anubhav, turn on your video till then.
Ma'am, because of internet connection is unstable, so I can't on my video.
Okay. Varshit, turn on your video. So I'll show you how the digital thermometers look like, right? So this is what the digital thermometer, I think, wait, I'll remove the background first of all. So now you can see easily, this is what the thermometer is. So it will have, you can see that it will have the point here, this one, where it does not have the mercury in it. And when we go at the end, second end of it, you can see a small button. What we need to do, we have to just press it. So just we have to press it. You can hear the sound like on and off sound. Now, when we press it, what we need to do after pressing, we have to, put it under the arms maybe, or maybe on the under the tongue, wherever like you want to get the temperature, we have to put there. So after, like for example, if I am holding it maybe in my hand, it will not come. Why it will not come in my hand? If I try to take the temperature of my hand, it does not like changing anything. Temperature is like same. Uh, Temperature is same. Like it is showing low, low. Why? What's the reason it is not showing any temperature when I am holding it in the hand?
Ma'am, because of skin.
So no temperature was given, no heat was given to this object, and that's the reason, like, what happened? It was same. It was showing low, 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 low. So when we are giving any kind of heat, then only it can start working on it, and then only the temperature will be accepted. Fine. So, and it has the reading of Fahrenheit. So there it is mentioned clearly that it has reading of Fahrenheit. So once we are done, we have to just off it. Same sound will be there for the on, same sound will be there for the off. And it is not like the other thermometer, we have to, dry it, we have to wet it. We can use it, we can wash it if we want, we can wash it, or we can use the wet tissue also to, clean the surface, because the same thermometer is being used by the different person at the home, right? So we can wash it, or we can use the wet tissue to use it again. So that is how it works, and it has dry cells inside this. So you can see the blue covering. When we open this, you will be able to see the cells inside the thermometer. So that's how the dry cells work here. Fine?
Yes, ma'am.
Okay. So children, now I have uploaded, I think